In this PowerPoint, we discuss the forces in two dimensions. So here we have a sign that's being held up by a pole that is pushing the sign out to the right, and then we have this cable that's pulling up at an angle, at a 40-degree angle above the left side. And then the weight of the sign is pulling downward. Now the question here is, what force is in the tension in the cable, and what force is this pole pushing out on? If you think about it, if this pole wasn't here, the sign would move toward the wall. It would accelerate towards the wall, which means that this pole is applying a force outward to keep it out away from the wall. So first thing, we need to find the force of gravity, which is going to be equal to mass times the acceleration due to gravity. That's 150 times 9.8, because that's the mass of the sign times 9.8, and that gives us our weight, which is going to be equal to 1470. So we have a weight that's equal to 1470 newtons. Now, in order to break this down, we're going to split each one of these forces into x and y components, and we don't want this to accelerate, so we expect our resultant force to be equal to 0 newtons. So the net force in each direction is going to be equal to 0. The force of gravity is completely in the y directions, but it's the negative y direction, so it's 0 in the x and then negative 1470 in the y. Force 1 is completely in the x direction, so it's 0 in the y direction. In the x direction, we don't really know what the force is yet, so we're just going to keep that variable as force 1. Force 2 is in the x direction and the y directions because it's up at an angle. So we need to find each component of this. Now, we don't know the amount of force 2, so we can keep that as a variable, but we do know that the x component is going to be cosine because it's adjacent to the 40-degree angle, and then the y component is going to be sine because it's opposite. The x component is going to be in the negative direction because it's pointing to the left, and the y direction is going to be positive. So we got negative force 2 cosine of 40 in the x direction, and then positive force 2 sine of 40 in the y direction. So this helps us set up our two equations. In the x direction, we have 0 plus force 1 plus a negative force 2 cosine of 40 is going to be equal to 0. In the y direction, we got negative 1470 plus 0 plus force 2 sine of 40 is going to be equal to 0. So here's our two equations. Alright, so we need to solve for our two forces. If you notice, this equation right here only has one force in it, and then this equation right here has both forces in it. So what I'm going to do is I'm going to rearrange each one. This one I'm going to kind of ignore that 0. I'm going to take this negative force 2 cosine of 40 to the other side. This one right here, force 2 sine of 40, I'm going to take the negative 1470 to the other side. So I got force 1 is going to be equal to force 2 cosine of 40, and then the force 2 sine of 40 is going to be equal to 1470. Now, to solve for force 2, we're going to go ahead and divide both sides by sine of 40. Sine of 40 equals 0.6428. So 1470 divided by that, that's going to give us a force 2 of 2287. Now we're going to take that force 2 and plug it into this equation right here in order to find force 1. We find that force 1 is going to be equal to force 2 cosine of 40. That's 2287 times cosine of 40. Cosine of 40 is 0.7660. We solve that and we get force 1 is going to be 1752 newtons. So we put these numbers back into our diagram, and we see that we still have force of gravity is equal to 1470 newtons, and we figured out that force 2 is 2287 newtons and force 1 is 1752 newtons. Now, in the y direction, the y component of force 2, which is the sine component, has to be equal to the force of gravity. And then the x component, or the cosine component of force 2, has to be equal to force 1, because all of these forces are balanced and the net force is going to be equal to 0. Alright, so this example, we have two cars pulling on a tree that with chains, trying to uproot it but not being very successful. One car is pulling at 3,500 newtons at 35 degrees east of north, and the second car is pulling with a 4,200 newton force at 20 degrees south of east. Determine the equilibrium force that the tree is applying. So we got these two forces, force 1 and force 2. They each have their angle, and we're going to break each one of those into components, because the net force in the x direction and the net force in the y direction are going to be 0 since it's not accelerating. Now the tree is going to be applying a force back, so we need to figure out what that force is. Now there's an x component and a y component to that, the force that the tree is applying. So we do the net force in the x direction. The x component of force 1 is going to be sine. It's the opposite, so force 1, which is 3,500 sine of 35 degrees. That's in the x direction. And then the x direction for force 2 is going to be cosine of 20 degrees, so 4,200 cosine of 20 degrees. And then we have the equilibrium force. The tree is applying a force that is balancing those two. So we can go ahead and figure out what force in the equilibrium force in the x direction. That's what that stands for, force of the equilibrium in the x direction. So we punch this in our calculator, 3,500 sine of 35 degrees plus 4,200 cosine of 20 degrees, and we get 5,954. Take that to the other side, and we figure out that the x component of the equilibrium force is going to be negative 5,954. We're going to do the same thing in the y direction. Net force in the y direction is going to be equal to 0. So the y component of force 1, that's going to be cosine, so 3,500 cosine of 35 degrees. That is upward, and so it's a positive direction. And then we have 4,200 sine of 20 degrees, which is going to be the y component, and that is negative because it's downward. And then we have the y component of the equilibrium force, and that's what we're solving for. Punch this in our calculator, and we get 1,431. Take that to the other side, we get negative 1,431 newtons. So we got the x component and the y component for the equilibrium force, and we're going to go ahead and make our right triangle out of it. The x component is going to be 5,954 newtons, and then the y component is going to be 1,431 newtons. So to find our equilibrium force, we have to find the hypotenuse of the triangle. So we do square root of negative 5,954 squared plus a negative 1,431 squared, and we get that the equilibrium force, the magnitude, is going to be 6,124. Then in order to find the angle, we have to take the inverse tangent of the opposite over adjacent. Well, the opposite is the y. The y is 1430 divided by the adjacent, which is 5,954. Inverse tangent of that gives us 13.5 degrees. So in looking at this, the equilibrium force is going to be equal to 6,124 newtons at 13.5 degrees. And if you look at that angle is south of west. In this example, we have a 76 kilogram person being pulled away from a burning building. So she's kind of hanging there, and the fireman's pulling her away. The question is, what is the tension in the two ropes? So that we have this one rope here that's pulling up at an angle, and this one rope here, this force or tension 2, that's pulling at an angle also. And at this moment, she's motionless, which means she has no velocity, she has no acceleration. So starting with a free body diagram, we have an upward force at an angle. So this one is going to be 15 degrees away from the wall. This one's at 10 degrees, and then we have a downward force of her weight, and you can see that right here. In order to figure out the net force in the x direction, I have to take all of the components of the forces in the x direction. Notice that tension 1, its x component, is going to be opposite that 15 degrees. So it's going to be tension 1 sine of 15 degrees, and that's also to the negative direction. It's to the left, so we put a negative in front of that. Force 2 is going to be to the right, so it's positive, and it's going to be cosine of the 10-degree angle. So it's tension 2, cosine of 10 degrees. So we add those together, and we get a net force of 0 in the x direction. To solve for tension 1, since we have two variables in this equation, then we solve for one of the tensions in terms of the other tension. Now we have to look in the y direction. The net force in the y direction is going to be equal to 0. So we have an upward component of tension 1, and that's going to be cosine because it's adjacent to the 15-degree angle. So tension 1 cosine of 15 degrees, and it's upward, so it's going to be positive. And then we have force of tension 2 sine of 10 degrees. That's going to be upward also, and that's opposite to the 10-degree angle. And then we got the weight downward, and the weight is not given, but we do have the mass of the person, so we can use that, the mass times 9.8, in order to find her weight. So tension 1, we already figured out, is going to be equal to 3.805 tension 2, or cosine of 10 over sine of 15. So I put that in here times tension 2, and then we had to multiply that by cosine of 15, and then we got tension 2 sine of 10 minus 76 times 9.8, which is her weight. So we calculate this out. This is going to give you a coefficient. We add it to this coefficient, and we get 3.849 times tension 2 minus 744.8, and that's her weight. We take that to the other side, and we divide by 3.849, and we get the total tension 2. So the tension of this one being held by the fireman is going to be 193.5 newtons. Now we take that, plug that back into tension 1's equation, and we get that tension 1 is going to be equal to 736.3 newtons.